Hello everyone, welcome to another Mobile Mapping Essentials webinar. Today we'll be hearing about mobile mapping data collection for mapping and GIS applications. And as usual, we'll also be taking questions during this session. And I'm just handing over to my colleague Peter now, and enjoy the webinar.
Okay. Good afternoon, good morning, good evening, wherever you are in the world. I hope you're all well and self-isolating and keeping healthy. So this mobile mapping presentation is focusing more at mapping and GIS, and will essentially follow an MX7 kind of workflow, but I guess is also applicable to MX8. So introduction to our mobile mapping systems. For those of you that aren't familiar, we have basically 3 products in our mobile mapping lineup from Trimble. The MX7, which is imaging only, the MX2, which is for sparse point clouds, and the MX9, which is dense point clouds and imagery, and could also be used for survey applications. But as I mentioned, today's focus is more on mapping, GIS, and asset management. So here's our product lineup, and for the purposes of demonstration today, we will focus on the MX7 imaging system and GIS asset management workflows. So the MX7, one of the main ideas behind this product was to remove some of the complexity and scariness, if you like, that is sometimes associated with mobile mapping systems. So it's a very simple product, and it's very easy to install, very simple to operate, and can be easily moved from one vehicle to another without too much hassle. And relatively speaking, in the mobile mapping world, it is relatively low cost, so it's an interesting entry-level product for somebody that perhaps wants to get involved in mobile mapping for the first time. So we really focused hard on removing the complexity and making this simple. So just to give you an idea, as far as data capture is concerned, when we calibrate these systems at our factory location, and quite often we will give the unit to a local taxi driver, a taxi company, and they will take it around our calibration route that we have in Germany. And the taxi guys are able to operate this thing themselves. So just an illustration that as far as data capture is concerned, very, very simple to use. So obviously a mobile mapping system by definition is particularly useful for corridor mapping, because essentially that's what you drive, a corridor, and we're capturing images that we're able to extract data using photogrammetry, and everything is controlled by a precise GNSS and inertial embedded system. And just about everything that we use, all the technology, is in that product that you see on the screen now. So everything is inside that tube. So the computer, the GNSS, the camera, everything is in that tube. Some of the typical applications that we've been involved in so far, so obviously road network and rail network management. So basically people creating asset inventories along those corridors, whether it be road or rail. We've also done some things in oil and gas, again, similar kind of corridor mapping where they maybe want to record the assets along a pipeline route, for example. So one of the very useful things about having an imaging system that you can very quickly go and capture data is not only, of course, do you get data that you're able to measure and extract deliverables from, but you get essentially an image log of the condition of that particular asset at a point in time, and so it can be used as a virtual inspection tool for inspecting assets. So rather than going in the field and going out in the bad weather, you can simply capture the data from your vehicle and do the inspection and extraction from the comfort of your office. And of course, there are some other benefits there that you know, doing surveys along busy highways is often quite dangerous. So you may need to do, you know, using traditional survey techniques. It may even be necessary to close a road or close a lane to do what you need to do. So from that point of view, mobile mapping is also very safe. So inside the MX7 is a 2 terabyte SSD where all the data is stored. We have the 360-degree cameras that are recording the field of vision, and then we have a Planix inertial system for giving us a very precise trajectory of the vehicle route. So what's in the box? We have the GNSS antenna, we have the 360-degree camera, which is actually 5 cameras, so 5 going around the 360 degrees plus 1 looking up. You may think that 1 looking up is not very useful, but actually it can be very useful for example, seeing under bridges or to very tall power lines, that kind of thing. We have the IMU, which enables us to carry on positioning in not so friendly GNSS environments, but it also very importantly provides us with heading, pitch and roll information as well, which is again very important for our photogrammetric extraction. And then there's a computer which is where the software runs that operates the system and stores the data on the hard disk. So what does it look like on a vehicle? We have a roof bar or a roof rack that is provided with the MX7, and then the MX7 is mounted on that roof rack. We generally use a second antenna that helps with heading, so we get a very precise GNSS heading, which is used to constantly calibrate the heading from the inertial system. And then quite often we will use a measuring wheel or a DMI that is installed on the wheel of the vehicle. This again gives us a distance input to our system, which can help in tricky environments where we lose GNSS coverage. So for example, if you went under a bridge or you're working in a downtown area with very tall buildings, it's another useful input to our navigation system. Inside the vehicle, we connect, generally speaking, to the vehicle battery. And we have a small power box. The power box also brings Wi-Fi down from the MX7. So we have a Wi-Fi hotspot inside the vehicle, just a local Wi-Fi hotspot that allows us to connect to the MX7 sensor head. This is then connected by a single cable to the MX7. And then we operate the system using, generally speaking, using a tablet. Just connect via Wi-Fi and use a web browser to access the operation of the MX7. However, you could also use a PC if you wanted to, or well, any device with a browser, basically, even a phone, if you wanted to do that. So this just gives an illustration of some of the platforms that we've installed the MX7 on. So, you know, it's very easy to use, and people tend not to leave it on the roof of the vehicle, but remove it at the end of each day. Very easy to move to a new platform. So we've had it on quad bikes or ATVs, cars and vans, trains, boats, a whole bunch of different platforms. So I would say this is one of the strengths of the MX7, is that you can consider it like another survey instrument that you could very easily move from one platform to another. So very simple to use from the data collection software. Very easy to control. I have certainly done this many times myself, which is operate the system whilst I'm actually driving. Whether that's recommended or not, probably not. From a safety point of view, if you were doing serious data capture, probably better to have somebody else operating the system, not the driver. But it can be done, to be honest. So we connect using a web browser to the MX7 from our tablet, and this runs something called TMI, which is our operating software. It basically has three main menus. One is settings. This is where you can configure your particular vehicle parameters and set up things like how often you want to capture images. Then we have our data collection screens, which basically shows us the images, shows us things like sky plots and RMS values of our various navigation parameters or positioning parameters. And then simply to start recording in mobile mapping in Trimble, we call them runs. So every time you start recording and then stop recording, that creates a run or a series of images, which we operate with in terms of our data extraction. So you can end up with multiple runs in one data collection mission. And that is simply by pressing that green record button, which then turns to red and says stop, and then you hit stop to stop recording. And then there are also some tools for transferring the data. So the data is recorded, as I mentioned, on an internal SSD. And then there are some tools to provide a facility to copy the data to an external hard disk so that you can then take that into the office and start working on it. Okay, so a little bit about deliverables. So the software that I'm going to show you is more in the manage and extract part of this workflow. So generally speaking, we have our collection phase, Then there's a processing phase where we might process the vehicle trajectory against a base station to get a more precise trajectory, and this is done in Applanix POSPAC software. And then we transfer the data to Trimble MX Asset Modeler, which is where you can do your data extraction and export extracted data to a variety of CAD and GIS packages, or even connect online to a database so that you're extracting immediately to an existing database, for example. And then a fourth step is to publish the data. Publishing the data is a way of sharing the data amongst a group of stakeholders within an organization. So, for example, if we took something like a municipality, the data might be interesting for a lot of people within that municipality, but they don't necessarily want to be experts at using or operating the system or extracting data, but they would like access to the data to be able to browse it and maybe take some simple measurements. And that can be done once the data is published simply from a web browser. So Trimble MX software, there are basically three things that we can consider. There's something called Content Manager. Content Manager is for managing large amounts of data. So if you were a regional government, for example, and you had lots and lots of data, it's important to have some tools to be able to manage that data. And for example, even be able to manage data sets of the same area that are collected over time. Asset Modeler is the software that I'm going to show you that is used for extracting data, and then Publisher is a way of obtaining a server license, an on-premise server license that allows you to publish data, make it available over the internet to share with anybody that needs access. So those are our three modules. Move on. Publisher. So Publisher allows you to access the data from a web browser to just be able to see the images on a map overlay and take some measurements. But there are also plugins available for this published data, for Autodesk, for Esri, for QGIS, which basically is a plugin of data extraction tools that is available inside your host software. So whether you're running, say, AutoCAD or ArcGIS or QGIS, you would get this toolbox of data extraction tools available to you within the host software that allows you to extract from the imagery directly into your host database. Where we don't have a plugin, the plugin is also available as an SDK or an API for other third-party software capabilities. So data extraction. So this is inside our Trimble MX Asset Modeler software, or TMX, we often call it. So the first thing you would see is your trajectory brought into the software, and you'll see here that the indicator on the trajectory is showing the precision. So it's a useful QA tool to be able to see what are my precisions like. You'll see most of this is at the couple of centimeter level. The example I'm showing you here, which is an area where we've got quite a lot of interest for the MX7, is for the fiber to home business, where they're basically installing new fiber cables to residential or business properties, and they need to basically do a survey of the area where that's going to happen so they can do their planning, and maybe need to survey at the end as well to do an as-built. So I'm going to show you this example. So this is a small housing area where a customer here wanted to do fiber to home kind of survey. So in this fiber to home example, one of the first things they may want to do is to plan the trench to put the cable route down this through this area basically. So here I'm just showing you how to extract. So we're doing this using photogrammetry, so there's no point cloud involved here. We get this rectangle, so it knows that it's intersecting a plane. So in this case, the plane is the ground surface. And then here we can add in some attributes. So if I've extracted a cable route, I'm saying what kind of surface it is, what kind of equipment needed to dig the trench, etc. So now we have very simply planned our cable route along this footway. So you'll see this one says asphalt because it's planned to go in asphalt. Quite often in the fiber to home business, they might be looking for the obviously the lowest cost way of installing the cable. So that they may actually put it in grass verge because it's cheaper. And of course, the MX7 data is perfect because it gives you that visual ability to optimize your route planning based on the environment. So I'm now just going to extract curb line. So this is just a manual extraction of a curb line, just to show you another way of extracting a line feature. So I'm picking up a feature that I've defined called curb line, picking my polygon tool, and I can simply redrive down this road and extract the curb line by clicking on it at regular intervals. So you see on the map display at the top there, the extracted data is being drawn into the database. So now I can add in the attribute information. So what kind of curve is it? It gives me automatically the length. Set up a parameter to automatically measure the length. So there's the curb line, and then there's the curb line overlaid in the image also. So next, I'm going to show you a different kind of feature. So obviously, essentially, this is a GIS kind of data system, so supports points, lines, and polygons. In this case, I'm going to use a polygon to pick up a manhole. In the UK, for the fiber to home business, they seem to call manholes chambers. So I've picked up a feature called chamber. So it's drawn my polygon. I can say what type of chamber it is, and add any notes. The area is automatically calculated and has been put into a particular field. Manholes are quite important for this business, so you see it appears on the map and in the image. Manholes are very important for this fiber to home business, I learned, because where possible, they would like to reuse existing infrastructure. So if there are things like manholes or chambers that can be reused, then obviously it's very useful to know where they are and what type of utility they support, and whether that could be used for their new infrastructure that they are going to be installing. So again, you see there's my manhole on the map. There it is in the image. Okay. Next thing that's important in this fiber to home business is to measure the offset from the main cable route to the actual property boundary. This is really important because this is the piece that the customer, the property owner, is actually going to pay for. So obviously the length of infrastructure or cable needed to connect that property to the main route is very important, because it essentially implies the cost of, or at least part of the cost parameters for that installation. So that's an illustration of how you could measure from the main cable route to the property. In this case, the cable route I've actually kind of extracted myself in TMX, but TMX will support any existing resources like existing GIS data, so that if that was known, so if you had a GIS or CAD plan of the existing cable layouts, that could be imported and used as part of the resources available to the operator. So as I've mentioned, TMX has a quite powerful GIS database behind it. So what I want to show you now are, so you can even do things like quite complex GIS kind of queries. So let's just say I've extracted a bunch of trenches, planned trenches, and I want to search for particular conditions. So I'm going to use my attribute surface type. So for each planned route, I've stored a attribute called surface type, and I'm going to do a search for soft verges. So it's basically searched through my database, and it's found all the verges that have the classification soft verge. And so, for example, these could be exported using that query to send to a contractor that deals with grass verges, for example, to go and dig those trenches. So it can be saved in shape or DXF format, whatever's needed. So I'm just saving that query here. Soft pages only, DXF format, let's say. Okay, so same example, this fiber to home example I'm using here. This is an example of maybe an as-built workflow. Once the cable's installed in the trenches, you'll see here, there's a trench there that's been rehabilitated by a contractor. So I'm using a inspection kind of workflow here to basically inspect that reinstatement of that trench and indicate whether it was done to our satisfaction or not. So very simple workflow, just to go along that trench. I'm just putting points on it wherever I've inspected it and indicating whether that was done to satisfaction or not. So once I'm into this mode of doing this, I can simply just say next item, and work my layer along the road. I stay with it inside the same inventory list, if you like. Now something different. I'm going to measure a post. So it's automatically dropped that to the ground. So I know the height of the post. So posts and poles are also interesting for the fiber to home business because they may use posts to put their infrastructure on. In many ways, it's cheaper than digging trenches. So it's another important aspect. So there's my point. And I can use any measure attributes along with that. So for example, I might want to look at what kind of equipment is already installed on there, and is there room for my new equipment that I'm interested in installing. So every time I extract a feature there, you'll have seen that there's something called snapshots. Whenever a feature is extracted, the software will automatically create a JPEG, which is called a snapshot of that particular feature. So that could be stored as an attribute in the GIS system, the actual JPEG, along with other metadata. Okay. Once I've been along and done my inspection, there's very nice inspection verification tool where it will quickly jump from one observation point and I can accept or reject it, goes to the next one. So this could be done by a supervisor. Can quickly just jump to all those observation points and can accept or reject those inspection points. So useful tool for verifying work that's been done, for example, by a subcontractor. I'm going to skip this one, but you can actually, OpenStreetView is the main, I'll play it anyway. OpenStreetView is the main map background that is available to you in TMX, but you can, if you have a web service mapping available to you, you can connect to that. So in this case, I'm going to add a connection to some large-scale ordnance survey mapping. This particular customer had an account with the ordnance survey for the very large-scale 1 to 12, 50,000 mapping. So providing you have login credentials, I could connect to that web service. It's called Master Map, and use that as my background rather than OpenStreetMap. So here you'll see my my surveyed area overlaid on, in this case, ordnance survey map. Okay, let's move on. So once data has been extracted, it can be exported, as I mentioned, typically shape format or DXF, but other formats are available. Data can also be published. So this illustration is data. So this is TMX on the left-hand side, but on the right-hand side is a typical data set in Publisher, which which is simply viewed in a web browser. So is available to share with anybody by simply sending them a URL. I also wanted to mention that for the MX7, there's also, so Publisher is quite an expensive product, but there are also this company Mapillary, which is an open source, free to use software that people upload, you know, cell phone photographs as kind of crowdsourcing database. Supports the MX7, so you can actually upload MX7 data to Mapillary. This is absolutely free, and there's some quite clever tools in Mapillary as well. But the downside is that it's available to everybody. So if you're concerned about sharing the data with other people, then you may need to think about having some kind of private account. You'll also notice it does things like automatic blurring of car number plates and people's faces, etc. There are plugins. So for the Publisher, you can have a plugin. So you'll see here is my data extraction toolbox. Oh, sorry. My data extraction toolbox sitting inside ArcMap. So this is ArcMap. Here's my vehicle trajectory. These are my images, and I can extract data from these images directly into my ArcMap database using this plugin. So I wanted to mention to you about some other workflows which might be interesting, which is to do with how we could work together with using mobile mapping data with something like Trimble's Teraflex product. So let's just say we wanted to map an area and extract a lot of the assets along the road for the first time. So we had lots of data to collect, and it made sense to do that quickly and efficiently with mobile mapping. So in this case here, we've taken MX7 data. We have a road sign. This is being extracted from our Office software. And of course, once that is extracted and is, say, in a shapefile format, that can be taken to the Trimble Terraflex database. So you'll see here is my road sign, and one of my attributes is that the condition is good. So that's how things sit at the moment. But sometime later, I would like to pick up these road signs and send them to somebody with a handheld device and Trimble Teraflex and ask them to go and inspect them, make sure the condition is still good. So I can set up a work order in Teraflex. So here's the same data also in ArcGIS now. So the data's been brought into ArcGIS. The condition is good. Here's a picture in my ArcGIS database. So now I've sent somebody out. This is maybe, let's say, a year or 2 years later. Sent somebody out with Trimble Teraflex with an iPhone and a Trimble R1 to inspect that asset. And using the field version of Teraflex, able to go through the workflow, inspect that, change the condition to poor in this case, taken a new image of that asset and saved that to the Teraflex system. So now when I look in Teraflex, the condition, same data set, but it's been updated. Condition is now poor. Same in ArcGIS. Data now indicates that the condition is poor. So quite an interesting way to think about mobile mapping and how it can be used in synergy with some of the other Trimble mapping and GIS tools. So, you know, the idea of mass data collection of large project areas with mobile mapping, but then future inspection of assets and update of assets using a tool like Trimble Terraflex. Just something on the performance of the MX7. It's a bit of an add-on here, really. This imagery here is MX7 imagery. This line work was surveyed line work with a total station. So simply taken the line work from the total station, put that line work into our mapping software and overlaid it on the image, and you'll see it fits very well. This was another test that we did with, again, a mobile mapping mission with an MX7, and then we extracted some points in the images and visited them with a RTK, with a Trimble R10. I just want to show you that. So the red dots in this image are RTK points that have simply been imported into our software. So they should fit, all being well, the locations that we chose as the control point location. So you can see they're coming in and fitting very well with features in the image. So quite a reassuring indication of the accuracy of the MX7 system. Okay, something additional. I've just thrown this in at the end, to be honest, but this is just another application. Something else I did was actually take an MX7 and using photogrammetry, tried to extract the data for a bridge, and then took that basic framework of points into SketchUp and built a model of the bridge. You'll see it here in Google Earth. I don't know how to control Google Earth very well, but you'll see here's my bridge model overlaid in Google Earth. So another interesting application. I've reached the end of the presentation, and I would just like to advertise our next mobile mapping webinars. On the 23rd, which I think is on Thursday, we have a follow-up to this presentation, really, looking more deeply at mobile mapping data and some GIS workflows and applications. I strongly recommend that presentation, which Marco Bello will do on the 23rd. And then on the 30th of April, next week, we're going to be having a looking at using mobile mapping data using Trimble Sight Vision and Teraflex for verification. And that is the end of my presentation for today. I thank you for your time. I see there's been a few questions which I think may or may not have been answered. I think Vincent has done a good job of answering them, but I'm going to hand over to Sophie again now. I think we have a few minutes if there's any further questions that people want to ask.
Yeah, we definitely have another few minutes, and if you have already asked your question and it hasn't been answered, maybe just stay online for another couple of minutes. We'll try and answer all the questions that have already been put out there, and if you have anything else that you want to ask, you can of course also stay online for another couple of minutes. We'll be here to answer all the questions that might come up. Thank you very much, Peter.